everyone, this video is on Charles's Law. Charles's Law states that if you have a fixed amount of gas at constant pressure, the volume of the gas is proportional to its temperature in Kelvin. Okay, so keep in mind that the temperature here has to be in Kelvin. Therefore, when we do calculations for Charles' Law, and actually for all of our gas law equations, the temperature unit has to be Kelvin. So for a given degree C, you have to convert to Kelvin, and you do that by adding 273. So if one quantity increases and the other increases also, so we have a direct relationship. Okay, and so if you take volume divided by temperature, this is a constant, and you come up with Charles's Law, an equation for it. So if the temperature is doubled, okay, so here we're at 200 K on the left, okay, in this cylinder the volume is 1. If we go up to 400 Kelvin, we double the temperature, we're going to double the volume. Okay, and so if you think about this, if you heat a gas, the molecules are going to expand. Okay, and so as you heat gases, the volume increases because those gas molecules get further and further apart, and therefore the volume increases. So we can explain this in an equation of V1 over T1 equals V2 over T2. Volume and temperature, and then the 1 stands for initial and the 2 stand for final. So this explains why warm air rises. So if you look here, we've got warm air there on land, and then we have cooler air over the sea. So as warm air is heated, okay, we just stated that if you heat gases, then they expand, right? And so heated air expands. Therefore, the molecules are further apart. Therefore, they're less dense. And so the density decreases, and this makes hot air rise. As for cooler air, okay, if you cool a gas, then the volume is going to decrease. So if you have a smaller volume, then you're going to have more molecules, and here they're air molecules, closer together. And so you have a higher density of air molecules. And this is why the cooler air for here is moving over the sea, and why the warm air rises is because of Charles's Law. All right, so let's do a practice problem. So we have a volume of 21 milliliters of a gas at 460 degrees C, and it is cooled to 80 degrees. So right away I want to remember that if I cool a gas, then the volume is going to decrease. If I decrease temperature, I decrease volume, and vice versa. So if I get an answer that's higher than 21, I know that I've done something wrong, okay? So pressure and number of particles do not change, and so what we want to write out here is our equation. So we have V1 over T1 equals V2 over T2. All right, V1 is 21 milliliters. T1 is 460 degrees C. V2 is what we're looking for, and T2 it's not going to let me write it there. T2 equals 80 degrees C. All right. Earlier I stated that we have to use Kelvin, so don't forget that. You're going to have to convert to Kelvin before you plug in to any gas law equation. So 80 plus 273, 353, 460 plus 273, Sorry, my pen always does that. Okay. Now we're looking for V2. So we have to rearrange the equation to solve for V2. So to do that, we have to isolate V2 by itself. So that means we have to do this. This is just algebra. So we get T2 times V1 over T1. Okay, so T2 times V1 over T1 equals V2. So let's plug in. T2 is 353 Kelvin. Okay, times 21 milliliters. That's our V1. T1 is 733. Kelvins cancel, so 353 times 21.0 divided by 733 gives us 10.1 milliliters. Okay, and this makes sense because the volume is less. So that's what we want to be sure that we see here. We started with 21 milliliters, so if we cool the gas, we know that the volume is going, Charles' law says if volume decreases, then if temperature decreases, then volume decreases. So we want to make sure that number is less than 21.0, and it is. Right? So there it is, and I will see you next video.